In this lecture, we're going to explore some simple ways to help kickstart your work on the creation of a database schema to a specification. And again, we're going to leverage forward engineering. And so what we'll do is we'll create a new schema, and we're going to call it Jon's WebDB. I already have a my WebDB out there, and I want to leave that alone. So I'm just going to create a new Jon's WebDB as an example. So let's create a new database, and I'm going to call it Jon's WebDB. And that creates the empty schema. And let's come here and prepare this to support an ERD, database diagram. And we'll use that for forward engineering. And let's come in here and have a new database diagram. And we're going to need to add some tables here. All right, we'll do it this way. And we'll create a new table and we'll call it users. Oops. Oh, it's going to create the column name. Okay. So we'll create the users table this way. And so we'll say user ID, and that's going to be an int, and it is not going to allow nulls. And let's go ahead and mark it as the primary key. And we'll have an email address. This is going to be a varchar 100, no nulls. And we'll make a first name field, varchar 45, no nulls, and a last name field, varchar 45, no nulls. All right, and let's go ahead and save that. And this table is going to be called users. And I'm going to drop that query. As a matter of fact, I'm going to close all the query windows. And I'm just going to refresh, see if we can build the ERD now. I had not refreshed before. All right. Well, we've got one table, so we can add it. Oh yeah, we have to have the table created. Okay. Now, once we're here, we can add a table. And new table. There we go. And let's call this downloads. And downloads is going to have a download ID. Int type, no nulls. And in fact, let's mark that as the PK. And user ID, that's going to be an int, no nulls. And download date. And let's make that a date time 2. Default of 7 is fine, no nulls. And a file name. And let's make that a varchar 50, no nulls. And a product ID. It's an int, no nulls. Great. And we need another new table. And this table we're going to call products. And products is going to have a product ID. And we'll make that an int, no nulls. And let's mark that as the primary key. And the product name. We'll make that varchar 45. Null is not allowed. Price. Make that a decimal 052. Null is not allowed. And a date added, and we'll make this another date time 2. Default of 7 is fine. And there's our tables. Now let's define some relationships between these tables. So we want user ID to be a foreign key here. Okay, and so we're defining a foreign key relationship. The primary table is users.userid. The foreign key table is downloads user ID. That is correct. This is fine. There it is. And let's do the same thing for the product ID. Drag that over. Oops, didn't quite catch the grab. And we're going to have a foreign key downloads products. The primary key table is products, where the product ID is the primary key. And then in the downloads table, product ID is the foreign key. That's exactly what we want. Okay, and okay. So very good. So we've got our relationships set there. This doesn't have to be quite that large. This doesn't have to be quite that large. And now this should be matching pretty closely, well, exactly our design specification. And we could actually go ahead and build this out now by saving it. And I'm going to call it Jon's WebDB ERD. And do we want to build it? Yes. Okay, so now if I come over here and refresh all this, there we go. Now we see that our tables are there and we see the columns that we've created. Okay, so a couple ways to build an index. One is we can just enter the create index statement directly with all of its parameters. Those can be kind of heady and hard to keep track of. So the other thing we could do is, let's see, if I look ahead here, we're going to want to build a unique index on email address. Okay, so one way I can do that is email address is in the users table. So I can come over here to users and I can find that email address and I can say modify, and I could come in here and come to indexes. And I can define an index here. This is exactly the same panel I will get if I do it through the ERD itself. Put that aside for a moment. So we can forward engineer it here. We can come and look at it indexes here. We can say we can build a new index this way. And right now that's disabled, not quite sure why. And my preferred way here is simply to go ahead and do it through the ERD. Here we have an existing index. So one of the things you can do if you want to learn how to structure the SQL, you can either read it out of the book or come in here and say we can take that that existing index and we can script that out, create to a new query window, and here it's a little bit stilted because it does formal naming of everything, and there's a whole bunch of parameters here that you get nice defaults for, so you don't have to add everything here if you're willing to go with the defaults, which are generally correct. But you know, this basically shows you how to use the alter table, add the table name, add the constraint, what the index is going to be, and the kind of index. So by the way, if you're wondering what a clustered index is, you can only have one per table. And when I tell you what it is, it'll make sense. The clustered index actually lays down the index order in the physical layout of the table, the physical record. So PK, you generally are going to add the data elements one at a time. You want to keep them in the natural order of the primary key. The clustered index is going to do that, and that's going to be the absolute fastest access, and that's usually where you need your fastest access. So you get a little bit of an advantage. It's more of an advantage, of course, when you're using spinning disks, magnetic disks, and whatnot, where you have seek time and the physical layout of the record really has a big impact on things. Less so with solid state, and of course, if you're all in memory, that's going to be a much lesser impact. But nevertheless, still, that's why your PKs are generally the clustered index on the table. So you only get one because it's got to be in that order. You can't have the physical storage in two different orders. So there's your layout. That's what a clustered index is. So everything else is going to be a non-clustered index after the PK, generally speaking. Okay, so interesting note. Let's go ahead and add the rest of the elements that we need here. So looking at our parallel exercise, we need to define the PKs also as not only PKs, but the also as identity columns. And identity columns we can use primarily when we're going to be building a sequence so that the data is automatically generated, like a key sequence, 1, 2, 3, 4, 5, as each record is ordered. You can also make a little sparser, value. You could put those, have them increment by 5. So you go, 5, 10, 15, 20. If you want to leave room for some reason, you can do that. A lot of times that's not necessary. But let's see what we can do here. If we come in and we look at the properties on the user ID and come down here, is it an identity specification? By default, it's not, even though it is the primary key. If we wanted to make it so, we can change it to is identity. When we do that, it'll change the identity specification to yes. It'll add the increment to 1 and the seed as 1. So if we have no records in the table, the first one we insert, if we don't provide a value for that key, it's going to be 1, the next one will be 2, and so forth. So we can just let it auto increment the key value for us. Sometimes that's a good thing, sometimes that's not such a good thing. Depends on what your design requirements are. All right, let's do that also for the download ID, which is the PK for the downloads table. Let's change that to yes. And also for the product ID, our specification is saying, yes, make that an identity as well. So good. Now they are all identities. And let's see what else we need to do. So we've done step 1, create the database. Step 2, create the tables and relationships. Step 3, define the user ID column and users table, products ID column, products table, download ID in the downloads table is primary key and identity column. So now we're on to step 4. In the downloads table, set the user ID and product ID columns as foreign keys. Well, I believe we've already done that because when we defined the relationship here, the SQL Server Management Studio has done that for us, and we can double check that, but I believe that is the case. Okay, it'd be kind of strange to have this depicted this way and not have it the case. So I think that has to be true. All right, number 5, define the columns so none of them allow nulls. We did that when we first created them. Let's change the view here on the table to custom and make a little bit more room. And we can see that it's all no nulls. Good, that's what we want. Okay, and step 6, use the Management Studio to create indexes for the foreign keys in the download table. Again, probably already been done. So here's a foreign key, and if we come and look at the indexes, and one thing I'll warn you, you've selected that field, you may think you're looking at the index just on that field. You're actually going to see the indexes for the entire table. And so, we have the PK. We do not yet have the foreign key index built there. So we're going to want to add that. Actually, it may be, I'm guessing that, have we saved this and built it since we built the relationships? Maybe not. So let's go ahead and save this. And yes, and that finished with no errors. Just to be safe, I'm going to dump this, and we're going to come here and reload it. Let's refresh it, open it up, come to the database diagrams. There it is. And again, let's take a look at the indexes. Nope, still only the one has been built. So let's go ahead and build out the foreign keys on the downloads table. Okay, so we need to add an index, and this index is going to be on the let's do the user ID table, user ID field first. So user ID, okay. And so it's going to be a foreign key index. PK indexes we usually name as PKs. General indexes as IXs. Unique indexes are often named prefixed with UQ. And for foreign keys, let's see if there's a type. Nope. So let's change the name here, and let's call it F key downloads. And then, so it's in the downloads table. And you don't have to follow this naming convention, but having some naming convention is very helpful if you need to understand things later. PKs, a lot of times they'll have a GUID, a globally unique identifier that the system tags on. You can just leave that alone unless there's a particular need for compliance with a specific naming convention. But that's not usually something you need to change with. But let's go ahead and give this a good name. FK downloads user ID, and there we go, and close that. So we should now have that. We come back here and look at the indexes. There it is, the FK index on the user ID, and we also need to add another one. And this one is going to be, what's the other foreign key in the downloads, is the product ID. So let's go ahead and change the column here to the product ID. And let's change the name to FK downloads product ID. Oh, FK downloads product ID. That looks good. Okay, so step 6, use the Management Studio to create indexes for the foreign keys in the downloads table. And then finally, use the Management Studio to create a unique index on the email address. Okay, so we haven't made a unique index before. Well, we have. The PKs are unique indexes, but they're also special because they're PKs. Let's come here and again, add an index. And this one, we're going to make it on the email address. I think I grabbed something incorrectly here. Oh, I need to add the I was redefining the PK, sorry. Didn't mean to do that. So we're now changing IX users. We're going to change this from user ID, and we're going to put this on the email address. Okay, and we're going to make it unique. And that's going to lock out, so you can't have two customers with the same email address. So that's a business decision that's been made. And there we go. And let's come down and change the name here. And let's call this UQ for unique users underscore email address. Okay, double check that that worked correctly. Check our indexes. And this one, email address, it is unique. Great, that looks good. Okay, and so use the Management Studio to create a unique index on the email address and product name columns. Okay, so let's see, where is our product name? Product name is over here. And so let's go to the indexes, and we're going to add a new one, not make the same mistake twice. And we're going to make this on the product name. Okay. And then this is going to be a unique index. And let's go ahead and give it a more meaningful name. So I'm going to name it UQ products underscore, and this is on the product name. Yeah, product name, UQ products product name. Close. All right. So let's see here. We've got it on the email address, the product name, and now we need a regular index, meaning not a unique index, on the download date column. Download date is back in downloads. So let's create an index. And we're going to add a new index. And this one is going to be on the download date. Okay. And so how about the name? IX downloads underscore IX downloads underscore download date. Close that. Save that. Yes. Finished with no errors. Let's go ahead and close that out. And now let's take a look what we need to do to document our solution. And let's go back and double check in our output and make sure we got our foreign keys definitions built correctly. I think they are built when we, by virtue of the fact of our making those relationships. But let's go ahead and check that. So let's have a new query window. And let's use Jon's Web DB. Good. And let's first exec the SP help on the users table. Okay, so we see our data types. We see that we've got the PK set as an identity. We've got a unique index on the email address. We've got PK users. And here's the foreign key reference. So that is defined, that is looking correct. And let's do the same thing for our downloads table. Run it. And you should probably make a checklist going through and analyzing the specification, or in this case, the instructions, the exercise instructions, to make sure that you are hitting everything you need to do. Check the data types, check the attributes, their names, what is the primary key, all those good things. It's always a matter of tiny details in DBA work. And here we have our foreign key product ID, foreign key user ID, a general index on the download date, and the primary key is downloads. That all looks good. Here's our foreign key constraints. So that all looks like it's doing what it's supposed to do. I'm happy with that. And the last one we need to look at is going to be the products table. Let's make a little more room here. Very good. Okay, and so I see the primary key, the unique index, and the identity on the PK, and correct data types and attributes, and that's looking good as well. All right, so it looks like we've successfully built that out and done so through forward engineering through the entity relationship diagram. I think that's a nifty way to get started. Again, you can certainly use create index and the alter attribute statements in order to build out the indexes individually. I think this is a much quicker way. And again, you need a little help with the syntax aside from hitting Google or looking at the documentation. If you come in to SQL Server Management Studio, look at an existing index or table that is similar to what you already have, you can just ask for it to be scripted and then take a look at how the script is built. That's a great way to learn this. The SQL Server Management Studio will really kind of help teach you SQL if you let it. So again, where we would do that, you want to see how the table is built, come to the table and say, let's see here. You can script table as create to, new query editor window. Bam. And here are all the statements needed to create the table, to add the constraints, to add the check constraints, not nulls, foreign keys, all of those sorts of things, and the SQL is right there. And you can imagine that you certainly could do this. It's not all that complicated, but it's time consuming and it's really easy to miss one thing or another. Using forward engineering is a nifty way to build out the model. You can build them out as empty tables, and then once you have the scripts, it's easy to take the copy of the scripts and integrate them into a bigger project that has even hundreds of tables. This is a quick and dirty way to kickstart it. Thanks for watching.